It mainly operates, it is simply an electronic circuit. It takes one or more input signal and it produces one output signal. NOT gate has only one input signal and only one output signal. Then while writing the truth table, if X is the input, X bar is the output. Then 0, 1. If 0 is the input, 1 represents the output. If 1 is the input, then 0 represents the output. What do you mean by tautology? The result of an expression, if it is always true, then it can be called as tautology. Welcome back to One and All. Myself, Vasanta, lecturer in Computer Science, Vidhyaashram, Pre-University College, Temple of Excellence, Mysuru. Today, we are going to start with the new chapter. The chapter name is Boolean Algebra. It is very easiest chapter. If you know the logic, easily you can able to write the answer. You can score good marks on this chapter. The total weightage of this chapter in the annual exam is 9 marks. In the annual exam, 9 marks you will get from this chapter, and in part A, 2 questions you will get, each carries 1 marks, and in part B, 1 question, as well as in part D also 1 question. Then 5 marks, here 2 marks, here 2 marks, totally 9 marks you will get in the annual exam from this chapter. Usually in part D, for 5 marks, you may want to get the question regarding kernel map, or we can call it as K-map also. When we come on today's class, first we'll discuss about introduction regarding logic gates, especially Boolean algebra, logical operators, as well as logic gates. Now, we'll start with the introduction. Here, this mainly used to design logic circuits. It is mainly used to design the circuit diagram, logic circuits. To design that, we need Boolean algebra, and it is developed by George Boole in 1854. First time in 1854, George Boole developed this Boolean concept, and he used to take one or more input signals and it produces only one output signal. In Boolean format, in expression format, in truth table format, in perfect induction method, we used to solve the problems here. And this logic gates deals with binary values and also call it as switching algebra. Because in 1 marks, you may want to get the question, what is the another name for Boolean algebra? That is switching algebra. Because in one of the year, you get that question, that is what is the another name for Boolean algebra? That is switching algebra. Then mainly here it will deals with binary numbers. What do you mean by binary numbers? Here the numbers are from 0 and 1 only. That is binary number. Here it mainly deals with zeros and ones. If I want, I can write 0 or 1. 0 can be called as false and 1 can be called as true. It takes in the format of zeros and ones, and then it will generate the results also in the format of zeros and ones only. This logic gate is simply an electronic circuit which operates on one or more input signal and produces one output signal. It mainly operates, it is simply an electronic circuit. It takes one or more input signal and it produces one output signal. Then the result of an expression is always true. Then it can be called as tautology. Because in one of the year, you got the question that, what do you mean by tautology? For example, consider one truth table. Here, I am having 2 values, A and then B. For example, the output A plus B. Then 2 variables, 4 combination, 0011, 0101. 0 plus 0, output becomes 0. 0 plus 1, 1. 1 plus 0, 1. 1 plus 1 is 1. If the result of an expression, if it is always true, see here the result, if it is always true, then it can be called it as tautology. What do you mean by tautology? The result of an expression, if it is always true, then it can be called as tautology. Then you have fallacy also. The fallacy states that when the result of an expression, if it is always false, then it can be called as fallacy. The same example here we are going to consider. For example, 2 variables A and B, the output A plus B. 2 variables, that's why 4 combination 0011 0101. Here 0 1 1 1. If the results here, if the result is false or 0, then it can be called as fallacy. Tautology means when the result, if it is always true, then it can be called as tautology. Whereas fallacy means the result, if it is always false, then it can be called as fallacy. There are three logical operators that are and, or, not. These are the three types of logical operators we are using, and, or, not. The value assigned to a proposition in respect of its true or false is called as truth value. Truth value is nothing but the value assigned to a proposition in respect of its true or false value is called as truth value. The statement which can be determined to be true or false is called as truth function. To determine whether it's a true or false, that can be called as truth function. Whether the result is true or false, to determine that can be called as truth function. When they come on logical operators, already I told you three types, and, or, not. Then what do you mean by this and operator? Which is the symbol we are using to represent and operator, or operator, not. One by one, now we'll discuss. First we'll take and operator. And operator is a binary operator. It is a binary operator. This operates on two variables. This operator operates on two variables. And operator is a binary operator. Then it will operate on two variables, operands. Here, the operation performed by AND operator is called logical multiplication. This operator can also be called as logical multiplication. And here, in between the variable, for example, I'm having A and B are the variable. In between the variable, if you represent dot operator, then it is logical AND operator. And here we are using the symbol dot operator to represent. The first point, here it is a binary operator. It will operate on two or more variables. Then here operations always here it can be called as logical multiplication. For example, x and y can be read as x and y, or I can say it as x into y. The and can be represented by using dot operator. Then when they come on the truth table, there consider we have two variables x and y. If it is two variables, then we are going to get x and y. Then the output represents how many combinations that we can identify. 2 to the power of 2, that is 4 combinations we are going to get. If it is only one variable, then 2 combination. If it is 3 variable, 2 to the power of 3, that is 8 combinations we'll get. Now whereas here only 2 variables we have, x and y, then output become x into y. Here consider 2 variable means 4 combination. Then 4 means half of the 2 and 2. Then first write down 2 times 0, then write down 2 times 1. Alternative 0, 1, 0, 1. Here the result, see 0 into 0, the output becomes 0 here. It means that here when all the inputs are 1, then only the output becomes 1, otherwise 0. Here see 0 into 1, 0. 1 into 0, 0. 1 into 1, 1 here. When all the inputs are 1, see in this case we have 2 variables. When all the inputs are 1, then only the output becomes 1 here. See, this is the Venn diagram. Then what do you mean by this Venn diagram? Venn diagram represent in graph format, in pictorial format we can able to represent. Consider here we have x variable and here we have y variable. And means this and this, each and everything has to be satisfied. Here if I consider this part is x and this part is y, then where exactly both the parts are combining, only this part are combined together. Then this is the Venn diagram to represent AND operation. Venn diagram. Because usually you will get the questions, write the Venn diagram for AND or not, like that you may get the question. It's very important. Here we have 2 parts x and y, then the place where both are combined, at that place you have to shade. For example, if you have the variable a and b, consider this is a and this is b. Consider 2 variables a and b. Then AND part, AND Venn diagram is here a part, here this is the a part and this is the b part here. Both the part where it is combined, that part you have to shade. Then only you will get the full marks Venn diagram for AND operation. Now is it clear? Next we will discuss about OR operator. Or means this or this. If any one of the input is true, output become true here. In this, we are using the operator plus to represent the operation. Here it takes more than one or minimum 2 inputs it will take, or more than 2 also it can take, and the output generation will be only 1. This operator is a binary operator. This operator operates on 2 variables. Minimum 2 variables be required. If I want more than 2 also I can take. And here this is also called as logical addition. To perform addition operations, we need this logical addition operator. And the symbol we are using plus operator to represent the operation. And if in this, for example, if you have x plus y, then it can be read it as x or y. Here, this or represent the plus symbol. In the same way, if I want to write the truth table, see, consider 2 variables x and y. Here, the output represents x plus y. In x plus y, if any one of the input is true, output become true. See the first case, 0 plus 0, the output become 0 here because both the inputs are 0. That's why output become is also 0. See the second case, 0 plus 1. At least one time we have 1. That's why output become 1. 1 plus 0. One time we have 1. That's why output is 1. 1 plus 1. That is also 1 here. This is the truth table for OR operation. Now, Venn diagram. When they come on Venn diagram, consider this is the first part, x part, and this is the second part. Then this or this x part also has to satisfy, as well as y part also it has to satisfy. Both the place you have to shade. Then only you will get the marks. For example, if you have the variables a and b, then consider this is a variable and this is b variable. Now, both this and this, we are not saying this or this, a part or b part. Then we have to shade both the part, a part as well as b part or b part. Both the thing you have to shade. Now is it clear? This is the Venn diagram to represent OR operation. Now is it clear? Then in the OR operation, it is also called as logical addition. Minimum 2 inputs it required. Here plus operator we are using, and this is a truth table and this is a Venn diagram. Next we'll discuss about NOT operator. What do you mean by NOT? It's just a reverse of your input operation. Maximum itself, here it will take only one input. NOT operator is a unary operator. This operates on with a single variable. Only one operator, only one operand we have here. Then here, the operation performed by NOT operator is also called as complementation. Complementation we used to call. And here, we are using the operator bar here. Bar. For example, x is the input, then output represents x bar. If a is the input, then output represents a bar. If a bar is the input, then what is the output? Output represents a. It is just a complement bar of the given variable. And x complement of x means just if you have considered if x equals 1, then what is the output? X equals 0. If x equals 0, then output become x equals 1. It's just the opposite of your input variation. Consider here we have one variable because already I told you NOT gate takes maximum itself only one input. Then here if x is the input, then x bar become the output. If input is 1, then what is the output? 0. If input is 0, then output become 1. It is just opposite of your input operation. While writing the Venn diagram, consider the outer part is x bar, then the inner part, only one variable, that's why the inner part can be called as x. Consider if you have here x, consider this is x bar. Then this represents x. Then if you want, you can write like this way, or you can shade like this way also. This is also correct. Like this also you can write the Venn diagram for NOT gate, NOT operation. Now is it clear for all of you? When they come on operator, 3 types, AND, OR, NOT. Next we'll discuss on logic gates. What do you mean by this logic gate? Logic gate is simply an electronic circuit. It takes one or more input signal and it produces an output signal. It is simply an electronic circuit which operates on one or more input signal and produces one output signal. While taking, it takes more than one input or at least one input. While producing, only one output we are going to get here. When you come on logic gates, there are three types once again, or NOT gate, OR gate as well as AND gate. When you come on operator also, there also we have three operators, AND, OR, NOT. When you come on gate also three types, AND, OR, NOT gate. These are the three logic gates we have. One by one now we will discuss. AND gate. AND gate, already I told you, AND means this and this. Everything has to be satisfied. Minimum two inputs here we required. When all the input signals are high or 1, the output is 1, otherwise the output is 0 here. When all the inputs are 1, then only the output become 1, otherwise here it is 0. The logical symbol for two input AND gate and the truth table is given below. Here this is the symbol to represent AND gate. Two variables. If you have three variables, then how to write? First one, for example, here I am going to take x and then one more is y and one more is z. Consider three variables. All the three will connect to the same part and then we'll write here D shape, then we'll connect that. Then what is the output? X into y into z. This is a symbol for two variables. This is a symbol for three variables. When you come on truth table, see, you just observed here x and y, then the output become x into y. Here, when all the inputs are 1, then only the output become 1, otherwise 0. See the first case, 0 into 0, 0, 0 into 1, 0, 1 into 0, 0, 1 into 1, 1 only. When all the inputs are 1, then only the output become 1, otherwise here it is 0. When they come on truth table for three variables, see, first 0 into 0 into 0, 0, 0 into 0 into 1. We have 2 times 0, that's why output becomes 0. Here, 2 times 0, that's why output becomes 0. Here 1 times 0, that's why output becomes 0. Here we have 2 times 0, that's why 0. Here 1 time we have 0, that's why 0. Here also 1 times 0, that's why output becomes 0. But if you observe the last one, all the inputs are 1, that's why the output becomes 1 here. This is regarding AND gate. Now is it clear? Next we'll discuss on OR gate. OR means this or this. We used to say, is it no? If any one of the input is true, output becomes true here. One of the input signal is high, then the output is high here. While writing the symbol, this is the symbol to represent OR gate for two variables. In the same way, if you have three variables, for example, x, y, z. All the three variables here we have. While writing, just curve this, then connect these two and then put one line. Then x, y, z are the input, then output represents x plus y plus z. This is a symbol for three variables and this is a symbol for two variables. Then truth table for two variables and this is a truth table for three variables. Already I told you in OR gate, if any one of the input is true, output becomes true here. See the first case, 0 plus 0, then output becomes 0 only. All the inputs are 0, that's why output becomes 0. If you observe the second one, 0 plus 1. 1 time 1 we have, that's why 1. 1 plus 0, 1. 1 plus 1, 1. Now is it clear? Andre, ಯಾವುದಾದರೂ ಒಂದು input 1 ಆಗಿದ್ರೆ output 1 ಆಗೋಗುತ್ತೆ. When all the inputs are 0, only on that case output becomes 0 here. Next, in the same way, truth table for three variables, then already I told you, if you have three variables, 2 to the power of 3, that is 8 combinations will get. If you have two variables, then 4 combinations you will get. Whereas here we have three variables, x, y, z. Then the output represents x plus y plus z. Then 4 times 0, write down 4 times 1. Then next 2 times 0, 2 times 1. Then alternative 0, 1, 0, 1, 0, 1 you have to write. Then you just observe 0 plus 0 plus 0 output becomes 0 here. Muru input to 0 there, that's why output becomes 0 here. You just observe the remaining case. 1, 1, 1, 1. Minimum 1 time 1 if you have, then output represents 1 here. In all the case, minimum 1 time 1 if you have, then the output represents 1 here. This is the truth table for three variables. Next, we'll discuss on NOT gate. Already I told you NOT gate is just a reverse of your input operation. NOT gate has only one input signal and only one output signal. Only one input and only one output. The output is always opposite of your input state. If 0 is the input, then output become 1. If 1 is the input, then 0 become the output. It's just opposite of your input operation. NOT gate is also called as inverter gate. It is very important. ಯಾಕಂದ್ರೆ ಒಂದು ವರ್ಷ what is the another name for NOT gate ಅಂತ ಕೇಳಿದ್ರು. On that time you have to write it is inverter gate. Then because of output it is not same as your input signal. It is just opposite of your input. That's why it is called as inverter gate. The output is sometimes called as complement or opposite of your input. Maximum itself, only one input here it will take. In one of the year, there's a question, which gate takes maximum one input? Then you have to mention NOT gate. While writing the symbol, this is a symbol to represent NOT gate. First one line you have to write, then here you have to write one triangle, at the end one circle and then one line. If A is the input, then A bar represents the output. Then while writing the truth table, if X is the input, X bar is the output. Then 0, 1. If 0 is the input, 1 represents the output. If 1 is the input, then 0 represents the output. These are the few logical gates. Whereas in this class, you have studied regarding what do you mean by Boolean algebra, which are the gates, which are the operators. Next class, you will study regarding which are the truth table, how to write the truth table. If you have 2 variables, then how to predict that. If you have 3 variables, then how to predict the truth table. Everything you will come to know. With that, perfect induction method. Then what do you mean by perfect induction method? Then how to substitute the value and how to prove that. Regarding that also you will come to know in the next class. With that, you will study regarding algebraic method. What do you mean by algebraic method? Which are the formulas there you have to apply and how to solve that. Then with that, you will study regarding duality. What do you mean by duality of an expression? How to write the duality of an expression? How to predict that? These are the things next class you will come to know. Thank you for all of you.